Hello, good afternoon. My name is Jessa and I am here to teach you how to perform this statistical tools listed using the Jamovi application or the Jamovi software. I only have 20 minutes to perform this, so please just bear with me. So let's start. So I do have a sample here for the one sample t-test. A research scholar wants to determine if the average weight of the student's everyday bag differs from a set value. Let's say this value is 25 kilos. So let's put the data. Meron ako mga data. So here, after you download or after you uploaded the data, just click the analysis in the upper left portion of your screen, then click t-test. You can see in the upper left of your screen the analysis, and click the t-test, and the drop down menu you can select the one sample t-test, and here you can now click the weight and transfer here to the dependent variable, drop in the dependent variable. Then next, put 25 because that's your null hypothesis and that we're going to test. Then we can also click the descriptive or even the normality test for assumption check. So here the result is we do have the t-test, the degree of freedom, the degrees of freedom, and the p-value. Here in the result, 0.311 is greater than the alpha value of 0.05, which means that we failed to reject the null hypothesis. So that's how Jamovi application is easy to use for this kind of calculation. So mas madali lang siya. So next, let's proceed to the paired sample t-test. So we also have data here, the before and after. So use an alpha of 0.05 for the test to determine whether there is significant increase in the rating of the agency after the 1-week video treatment. Assume that the differences in rating are normally distributed in the population. So here, next tayo. So once you uploaded your data, same pa rin, just click the analysis in the left portion of your screen, then t-test, then paired sample t-test. So click the two variable you want to compare. So here, need to click the before and after, and click this arrow. Then next, and for the hypothesis, it's measured 1 is less than measured 2 because that's before and after. You can also click the descriptives and then the normality test for assumption check. So here in the result, there's a t-test value, the decrease of freedom, and the p-value that tells you whether the difference between the two groups is statistically significant. So if the p-value is less than the alpha value of 0.05, means that we can conclude that there's a significant difference between the two conditions. But if the p-value is greater than the alpha value of 0.05, it means that we failed to reject the null hypothesis. So here in the null hypothesis, normality test, it's the p-value is 0.978, so it's normally distributed. And for this here, same pa rin dun sa result natin kanina from the Jamovi, ito yun. The p-value is 0.22, so it means that it's less than the alpha value of 0.05, so we can conclude that there's a significant difference between the two conditions, and we can now, or the researcher can rejects the null hypothesis. And so next, I assume that we already know the definition and functions of the independent sample t-test. So let's proceed to the example. So suppose we want to conduct a hypothesis test to determine whether the average annual wage of two of the future careers of the students, say advertising manager, is different from the average annual wage of an auditing manager at the 5% significance level. So because we are testing to determine whether the means are different, our hypotheses are this. So where advertising managers are the population 1 and our auditing manager are the population 2. And this will be our data that will be uploaded to the Jamovi. So let's proceed to Jamovi. Same process. After uploading, in the upper left portion of the screen of the Jamovi, there's an analysis. You just click that one, then click t-test and then independent sample t-test. Here, the position, just put it to the, or drop to the grouping value variables, then the wage to the dependent variable. Then the Jamovi will automatically calculate the result. And for the assumption check, just click the normality and the homogeneity test. And if you suspect an equal variances, just click the Welch t-test option instead. And here's the result. As you can see, there's a statistic, same. The statistic, the DF, and the p-value. The statistic, which is the t-value, which used to compare the means, the degrees of freedom, which is the number of observation minus 2, and the p-value, which is the significance level of the test. So if the p-value, if p-value is less than the 0.5, we reject the null hypothesis and conclude that there's a significant difference between the two groups. And if the p-value is greater than the 0.05, it means that there is no significant difference between the two groups. So by using Jamovi application, the Jamovi software, it makes our life easier and makes easier to compute. So thanks to Jamovi. And here's another same result, pinalaki lang to be able you to see it clearly. So here the p-value is 0.025, which is less than the alpha value of 0.05. So which means that we reject the null hypothesis and concludes with 95 confidence. The researcher reject the null hypothesis and can say that there is a significant difference between the average annual wage of the advertising manager and the average annual wage of the auditing manager. And if you can observe, the mean portion of the result for the wage of advertising is 70.7, and for the auditing group is 62.2. Then we can conclude that the advertising group is earn more, the advertising manager earn more on the average than the auditing manager. Sana all. So let's proceed to one-way ANOVA. So one-way ANOVA is an analysis of a variance. It is a statistical test used to compare the means of 3 or more independent groups to determine if at least one of the group means is significantly different from the others. So we have an example here. For example, you could use a one-way ANOVA to understand whether exam performance differed based on test anxiety level among students, dividing students into 3 independent groups: the low, the medium, and the high stress students. So we have an example here. Here. So just like the others, after uploading the data, just click the analysis in the upper portion of the screen, then click ANOVA, then one-way ANOVA. And after that, just drop the group to the grouping variables and creation time on the dependent variable. So in the dependent variable box, we selected continuous variable. In the dependent variable box, we selected continuous variable that we want to compare across the group. And in the grouping variable, we selected the categorical variable that divides our data into groups. So the result will show the ANOVA table, which includes the F static and the P value. So the P value is 0.055. If P value is less than the 0.05, we reject the null hypothesis and concludes that there's a significant difference between the two group means, between the group means. And if the P value is greater than 0.05, we fail to reject the null hypothesis and concludes that there's no significant difference between. If your ANOVA is significant, you may want to know which group differ from each other. So choose a suitable test, click to key, and then flag significant comparison. And if you can see, there's the normality test is not normally in the assumption check. The normality test is not normally distributed. The data is not normally distributed, and also in the post hook test, there's no group that are significant. So by following these steps, you can easily perform a one-way ANOVA and analyze the result. So let's proceed to the next statistical tool, which is the Pearson R. So Pearson's R is also known as the Pearson correlation coefficient. It is a statistical measure that quantifies the strength and the direction of the linear relationship between two continuous variables. So R ranges from -1 to +1. -1 indicates a Pearson negative linear relationship. 0 indicates no linear regression. So here's the example. National Safety Council released the following data on the incident rate for fatal or lost working time injuries per 100 employees for several industries in the 3 recent years. So here's the data. So compute R for each pair of year and determine which years are most highly correlated. You can select more than 2 variables if you want to calculate the correlation matrix between multiple variables. So in the correlation coefficient section, ensures the person is selected. So Jamovi also allows you to compute the correlation coefficient, but Pearson R just leave it as the default. So after that, you can see the result in the result area. So here, you click the analysis, then regression, then correlation matrix, and then click the year 1 to 3. And the result, the Jamovi automatically calculate the result. So Jamovi will display correlation matrix showing the Pearson R coefficient each pair of variables. So the matrix will also include p-value to help you assess a statistical significance. The strength and direction of the correlation can be interpreted based on the value of R. So if R is greater than 0, it's positive correlation. So if R is less than 0, negative correlation. And if R is equal to 0, no linear regression. So here, year 1 and year 2, year 2 and year 3. then year 2, year 1 and year 2. See here the correlation coefficient interpretation for year 1 versus year 2, the R is 0.975. For year 1 versus year 3, it's 0.957, and year 2 versus year 3, it's 0.985. So the correlation measures the strength of the relationship between X and Y. So the closer the absolute value of R is to 1, the stronger the linear relationship. So relationship between the variables. So notice that the variable year 2 and year 3 have the highest positive correlation coefficient. Thus, among the three, they are the most highly correlated years. So the next statistical tool is the multiple linear regression. So multiple linear regression is an extension of a simple linear regression where the goal is to model the relationship between one dependent variable and two or more dependent variables. So in simple terms, it allows you to predict a dependent variable, which is the y, using multiple dependent variable, the x's. So multiple linear regression also is a powerful statistical method that allows you to model the relationship between one dependent variable and multiple independent variables. It is widely used for prediction, forecasting, and understanding how various factors influence an outcome. By analyzing the coefficient, the model helps in understanding the individual contribution of each predictor, while the overall goodness of fit statistics assess the model's predictive power. So here's the example. So a model is set up that predicts the body weight of a person. The dependent variable is thus the body weight, while the height, age, and gender are chosen as independent variable. So here, so just like the others, just click the analysis in the upper left portion, then click the regression and linear regression. Then this weight, just put it to the dependent variable box. Then the covariance is the height, age, and for the gender, just drag the factors. So the Jamovi automatically calculate the result. So if you want to know the assumption, if you want to check the assumption for the normality test, you can check also. And for the QQ plots for residuals. So the DV, the DV is the variable you want to predict. Then the covariance is the predictions that may influence the dependent variable. So as a result, so here, this table shows that 75.4% of the variation in weight can be determined by height, age, and sex. So here's the equation. So the equation shows, for example, that if the age increases by 1 year, the weight increases by 0.297 kilogram according to the model. So in the case of the decomtumous variable sex, the slope is to be interpreted as the difference. According to the model, a man weighs 8.9 kilogram more than a women. So if all independent variables are 0, the result is a weight of negative 15.49. So the standard coefficient beta are measured separately and always range between -1 and +1. So the greater beta is, the greater is the contribution of each independent variable to explain the dependent variable. In this regression analysis, the variable age has the greatest influence on the variable weight. So the p-value indicates whether a variable has a significant influence. So p-values lesser than the alpha value of 0.05 are considered as significant. So in this example, only age can be considered as significant predictors of weight of a person.